In this video, we will be discussing how to describe a graph, box plot, histogram, either one is acceptable. And we will then go on to how to compare two box plots. These are two skills that are very important for students to get in middle school, continue on in geometry, and then finally in AP statistics. And on the AP statistics exam, many times they are graded. Their first question that's being graded has to do with either describing a graph or comparing a graph. And there are so many students that do not receive full credit for this just because of some just minor errors. So I kind of want to walk you through that today. In statistics, we do what is called CUSS the graph. Some people use SOX the graph, but students kind of like to say CUSS the graph. But the C stands for center. And the center of the graph can be the median if you're talking about box plot. It can be the mean if you're talking about a histogram, whatever information you've given. So the center of the graph. So for this graph over here on the left, there's no context to this graph. So they would not, there'll always be context when we're talking about a graph on an AP exam or in a problem. But for this example, there happens to not be context. And you'll see that the median of the graph is above 20. So we would say that the center or the median of this group of data is approximately 20. Just in case it's a little off of 20, we would always use the word approximately. The U stands for unusual. And anything unusual would be in a box plot, it would be your outlier. Notice we have an outlier here at about 91, 92. There's an outlier. If you were looking at a histogram, unusual features might be also be gaps that would appear if you had a histogram that had any bins that were empty in the middle of the graph. We could say that there's a gap between these two numbers. The first or one of the S's has to do with shape. And this graph over here on the left is actually skewed to the right because there is more room on the right side of the median than there is on the left. So this is skewed to the right. A symmetric graph, the median would be about in the middle of not necessarily the box, but of the whole group of data. So it would be considered symmetric, and then skewed to the left would be opposite of this, where there's more room or it's more spread out on the left side of the graph. And then the last S is spread. And spread has to do with your range. Here, the data values, we would say if we include the outlier, the data set has a range between 10 and 90, approximately 10 and 90. Without the outlier, there's a range from 10 to about 67, approximately. We can also use spread as the IQR, which is the range of this box. So the interquartile range is the difference between Q3 at 40 and Q1 at about 14. So 40 minus 14 is 26. And we would say the interquartile range is about 26 for this data set. So that's just kind of a quick review on how to describe those. Now, if this had context, let's say we were talking about the number of at-bats for a group of baseball players, that context needs to be in one of the sentences. So if I started off by saying the median number of bats for this group of baseball players is approximately 20, then we can then go on to make the other descriptions without that context. Context, it has to be in one. And that's where a lot of students lose points on the AP Stats exam and on other standardized tests that have to do with describing. Now, that's pretty simple, not too hard for us. The problem is when we get into comparing graphs, and I love this lesson 3 in our unit because it walks the students through the words that they need to know on comparing. For example, here in part A, it says complete the sentence to compare the center of the two box plots. And notice that if we're comparing the weight of Japanese cars to the weight of American cars, it's asking you the approximate median weight of an American vehicle is about 4,200 pounds, which is heavier than the approximate median weight of a Japanese vehicle of about 3,300 pounds. Okay, and a lot of times you want to have them write the words about. Okay, it's just really huge to use the words lighter, heavier. If we look at part B, we're talking about comparing the spread. They're using the middle 50% to compare the spread. The middle 50% is between 2,700 pounds and 4,000 pounds compared to the middle 50% between 3,400 pounds and 4,800 pounds. We see that 25% of the Japanese vehicle weighed less than all of that. So if we look up here, this is the lowest American vehicle weight, and this is 25% of Japanese. So there's 25% that are lower, that weigh less than the lightest American car. Okay, so those are kinds of things that they can use as comparison. In part C, we see they're talking about the shape, where one is that both of them are actually skewed towards the heavier end. So if we look, we notice that from the median to the right has more area, or is longer than the left side. And that's true definitely on American with that outlier in there. We could then say, we've talked about everything but unusual features, but that the American does have an outlier that weighs more than any of the others at all. And the Japanese do not have any outliers. So you want to make sure that they're using comparison words to do this and not just describing. As an AP reader for the AP statistics exam, many times I've been scoring the free response question that asks them to compare two graphs. And the points that they are missing are points that, one, they do not include the context. So having students include the context on the very first sentence they write is very important. And two, when they're asked to compare, they make a list and they basically and they write the word CUSS on the test, and they basically CUSS this graph and they CUSS the other graph, and they never use these comparison words to compare the two, and they get therefore a 0 for that question, because the directions say to compare, and if they never use the comparison words, they'll never get a score. Okay, I hope that helps with describing and comparing graphs.